Okay, so we are going to build a cladogram together. Sorry. There are some questions like this on the air test. So let's review some of the stuff you're given in this chart. You've got a list of shared derived characteristics. So dorsal nerve cord, notochord, paired appendages, vertebral column, paired legs, amnion, mammary glands, placenta, canine teeth short, foramen magnum forward. You don't have to know what any of those things are, because they're telling you for which groups these are true. So we'll come over to here, and let's look first. Here's our first shared derived characteristic. So this is going to be something that is true for every single group on that graph. So you should be doing these notes along with us. So we need to find a shared derived characteristic that's true for every group listed here, and these are actually sort of species. And it sure looks like dorsal nerve cord is true for every single species here. So this is going to be dorsal nerve cord. And remember, dorsal is your back, like dorsal fins in the water, shark fins. So the dorsal nerve cord is a nerve cord down the back of the body. That would be like a spinal cord. Okay, so we know that dorsal nerve cord is true for everybody. We've got that checked off. We've used that. Well, is there a species that shares a dorsal nerve cord with everybody? But, well, wait. What's our next shared derived characteristic? There's got to be something that's true for all but one species. So if we look here and we look at paired appendages / vertebral column. Oh, and paired legs. Well, we're going to just go in order. Paired appendages / vertebral column is true for everybody but who, Seth? Who's that not true for?
Lampreys.
Lampreys. And lampreys look like something out of somebody's nightmare or a horror movie. I'll show you a picture later. So, okay, we're going to put paired appendages / vert column, vertebral column. And that's just having a bony backbone. So paired appendages and a vertebral column. And we said that lamprey, the nightmare species, have a dorsal nerve cord, but they don't have paired appendages. They don't have a vertebral column. They don't have a they have a spinal cord, but no vertebrae to protect it. All right, so we've got that. Whoops. Now, let's look and see if there's anything that has paired appendages but is missing whatever comes next. So let's look. Look at this. So everything that has paired appendages has paired legs. There's nothing that has paired appendages but not paired legs. So this box is blank. We could think of species that would fit in there. Fish have paired appendages. Pectoral fins are paired appendages, but they're not legs. But it's good practice to see a cladogram where we have a missing box there, because when they do these on the air test, there will be cladograms where you don't have to fill in all the boxes. So it's good practice to think through that critically. All right, so let's look at, so we've used paired legs. Let's go back to our species. What's the next thing? Well, let's go back to our shared characteristic. So everything except lamprey has got paired appendages and paired legs. Amnion looks like something drops out. So amnion, bullfrogs, have paired appendages, paired legs, but they don't have an amnion. Do you remember what the amnion was? It's the membrane on the egg. When you peel the hard-boiled egg, it's a little white membrane part. It's also the amniotic sac that babies develop in. Okay, so amnion is our next shared derived characteristic. Can't spell amnion. And we know that bullfrogs don't have it, and that's why frogs have to lay their eggs in water. All right, so we've used amnion, we've used bullfrog. So let's get back to our characteristics. And I'll start, well, first of all, questions so far. Mammary. So we're looking at the next characteristic, which is the next one where we drop one. Is there anything that's got an amnion but no mammary glands? Snapping turtles. So we know that mammary glands will be our next characteristic. And we know that snapping turtles are the thing that has an amnion but no mammary glands. I'm just going to write SN turtle. All right. Now, mammary glands, that's the defining hallmark of what group? Sounds a lot alike. Furry, nurse their young. Mammals. Mammals. Us and bats and coyotes and cats. So we've got 3 boxes left. We have 3 species left. Is there something that, so let's look at the next characteristic actually to see where things drop off. Placenta. What's the placenta? It is a big chunk of steak that you all grew on. Ew, it's a giant piece of muscle that runs the blood exchange between a fetus and the mother. And placental mammals have a placenta. Rhesus monkeys and humans have a placenta. Who doesn't have a placenta but is a mammal? Kangaroos! They're marsupial mammals, like possums. So placenta is there, and the kangaroo has mammary glands. They do nurse their young, but they don't have a placenta. So they give birth when the baby's like half done, and they keep it in the pouch, and they just nurse it. It's really a pretty cool system. Okay, so we've got 1 shared derived characteristic left and 2 species left. So if we look at this chart, I'm going to get rid of all this. Just leave placenta and canine teeth short. So you know your canine teeth are the pointy ones. Canine teeth short, humans have what are called shortened canine teeth. A lot of mammal and primate species have much longer canine teeth than us. So who has a placenta but doesn't have short canines? That would be the monkey. That would be the rhesus. So we're going to sort of abbreviate this. Canine short. And the rhesus monkey, and if you ever look at a rhesus monkey, they could tear your face off with their giant teeth. So the other piece of that characteristic, the foramen magnum short, there's a hole in the back of your skull where all the nerves go in, and that's that structure, the foramen magnum. And on some species it's upright, and on some species it's forward, and on us it's slightly forward. So humans would go here. And you know, we can arrange characteristics in a whole lot of ways. These cladograms are a little bit more flexible in terms of structures, because we could start looking at enzymes that humans have. We could look at different configurations of chemicals in the body. With the cladograms that are based on biological relatedness, like this, they're a little bit less flexible. They tend to be a little bit more rigid. Do you have questions on any of these? Does this seem fairly straightforward? So, you've got these air test questions to do. These are due tomorrow before you walk in. When you walk in, we're going to go over these. Then there's going to be a new set. There'll probably be like a 2-question quiz to get you a little assessment grade. Then we're going to have a new set of notes because we're going to go into the chemical evidence. We're going to start looking at chemical cladograms. So on these, the ones I'm going to say, because I had a few people in the other class who were like, can I ask you a question about this? No, unfortunately, and I don't like saying that. I want you to read these to the best of your ability. Try to understand them the best you can without any help, because on the air test, I can't come over and help you. We will go over every single one of them tomorrow. Every single one in detail. You'll get all your questions answered tomorrow. But for today, I want you to read them carefully and do them to the best of your ability. So that's what I got. Questions on any of this? I'm going to give you the rest of the time to work on the air test questions. You can probably so by tomorrow you need to have these turned in along with the full notes. That includes the vocabulary slide at the front where you had to do it in your own words. And that's all we got. That's it.